To us, water striders are almost magical. I mean, come on, they're literally walking on water. But come down to their level, and it's a bit more sinister. These delicate little bugs have figured out how to master the elements and to exploit those who can't. So how do water striders float where others sink? The answer is those crazy long legs. The answer is those crazy long legs. Water is pretty sticky stuff. It likes to hold on to itself. It sticks together especially well right at the surface. If you're small, it can actually hold you up, as long as you don't break through that surface tension.
So let's talk about that surface tension a little bit. Because water molecules have a bent shape and electrons are not shared equally between hydrogen and oxygen, hydrogen bonds form among the molecules. Due to the attraction among the atoms that make up water, the surface of the water can support a water strider through surface tension. This is for my biology students, and currently we are on lesson 6.3, Water and Solutions. On page 161 of your textbook, let's talk about water's polarity. So water molecules are formed by covalent bonds, bonds that share, they coexist. It's that link to hydrogen atom bonds to the oxygen atom. So water molecules have a slightly positive end near the H atoms and a slightly negative end near the O atom. Molecules that have an uneven distribution of charge are called polar molecules, meaning they have oppositely charged regions. When a charged region of polar molecule comes close to the oppositely charged region of another polar molecule, a weak attraction forms. A hydrogen bond is an example of a weak attraction involving hydrogen atom and a fluorine, oxygen, or nitrogen atom. A hydrogen bond is a strong type of van der Waals force.
The properties of water make it well suited to help maintain homeostasis in an organism. Water's chemical composition consists of 1 oxygen atom and 2 hydrogen atoms. Water is polar, which results in a slightly positive charge on the hydrogen atoms and a slightly negative charge on the oxygen atom. As a result, it forms hydrogen bonds. Hydrogen bonds are weak bonds involving a hydrogen atom and a fluorine, oxygen, or nitrogen atom. Liquid water becomes denser as it cools, yet ice is less dense than liquid water. As a result, nutrients in bodies of water mix due to changes in water density during spring and fall. Because water is adhesive, it forms hydrogen bonds with molecules on other surfaces. Water is cohesive, and its molecules are attracted to each other due to hydrogen bonds. This attraction creates surface tension. It's pretty amazing how many properties water has. No wonder it's such an important molecule for life.
So while we're on the subject of water, let me remind you what a mixture is. It's a combination of 2 or more substances in which each substance continues to retain its individual characteristics and properties. Therefore, mixtures can be either homogeneous or heterogeneous. And let's write down and talk about specifically about a homogeneous mixture. So it's a mixture that has a uniform composition throughout. It's all the same, okay? So a solution is another name for homogeneous mixture. In a solution, there are 2 components. The first one is a solvent, or a substance in which another substance is dissolved. The other component is a solute. That is where a substance has been dissolved in the solvent. A heterogeneous mixture is when the components in a mixture remain distinct. It is a heterogeneous mixture. A suspension is a type of heterogeneous mixture where the particles settle out over time. A colloid is a heterogeneous mixture in which the particles do not settle out. So back to that second bullet point right here. Kind of think about oil and water, what it looks like, and then you shake it up, and then if you give it a little bit of time, it'll eventually separate. On page 164 of your textbook, it moves on to acids and bases when it comes to mixing things with water. So many solutes readily dissolve in water because of water's polarity. Substances that release hydrogen when they are dissolved in water are called acids. Substances that release hydroxide ions when they are dissolved in water are called bases. So pHs and buffers. The amount of hydrogen or hydroxide ions in a solution determines the strength of an acid or base. The measure of concentration in a solution is called pH. So acids that have pH values less than 7 and bases have pH values greater than 7. And a buffer is a mixture that can react with acids or bases to keep the pH within a particular range. Again, this chapter is just really a large review of what you've already had. So for the most part, you should just have to do some refreshing and studying. But if this is all Greek to you, I would highly suggest you come talk to me. And make sure that you can clearly answer the y to the third power to how does the structure of water make it a good solvent? What are the similarities and differences between solutions and suspensions? And what are the differences between acids and bases? Although it's right now, this chapter is actually going to continue for a majority of this school year. And the reason why is because everything having to do with genetics, DNA, RNA, it's all goes back to the base of its chemical foundation and formula and what acts with what reacts with other, covalent, ionic, what's afraid of water, what's phobic, and what's not. These types of things are going to continue to come up throughout for I'd say the remainder of the year. So please do learn them now because, again, they are not going to go away.